Finite Math, Section 2, 1, Part 3. Part 2 actually got prematurely cut off. I ran out of storage space, so we'll call the other one 2, and this is 3. Okay, so you have to know the rules, and that's what we got on this page here. Gaussian elimination is another method of solving systems of equations. The method utilizes matrices to solve the system. Things that you're allowed to do in Gaussian elimination. You can multiply any row by a non-zero constant. You can interchange any two rows. Number 3, you can multiply any row by a non-zero constant and add it to a second row. I'm going to show you some examples of each of these rules. They're actually kind of simple. Number 1, replace any row by a non-zero constant multiple of itself. So here's the matrix we're starting with. It's actually the same matrix each time. But let's say I wanted to multiply 3 times each element in row 1. Okay, first of all, you'll notice the notation here. These are called the instructions on how to go from this matrix to that matrix. This says take 3 times everything in row 1. Here's row 1. So 3 times 1 is 3. 3 times 2 is 6. And 3 times 5 is 15. Second row stays the same. And usually you just work on one row at a time. So this is what it means when you replace any row by a non-zero constant multiple of itself. In layman's terms, you can multiply any row by a number. That's what I did here. I just multiplied by 3. Okay, the second rule that we could do is we can interchange any two rows. Notice the instructions. I got R1 and R2. And when you put an arrow like this, it's kind of hard to see, but it's a double arrow pointing each way. That means you're interchanging. So 1, 2, and 5 in the top row become 1, 2, 5 in the bottom row. And the 7, 4, 8 in the bottom row now becomes the top row. Okay, then the third item, replace any row by the sum of that row and a constant multiple of another row. In layman's terms, that means you're going to multiply by some number and add it to another row. So this says I'm going to take 2 times row 1 plus row 2. So I'm not doing anything. Row 1 stays the same. It's not changing. This says take 2 times row 1. So 2 times 1 is 2. And then add it down here to the 7. And that gives you 9. 2 times 1 is 2. Plus 7 gives you 9. Now you got to go all the way across, do the same thing. 2 times 2 is 4. 4 plus 4 is 8. 2 times 5 is 10, and 10 plus 8 is 18. So I changed the bottom row. Notice, since I was changing the bottom row, I line my instructions up with the bottom row. Okay? Now it didn't matter here because I was flipping the 2 rows. You go back up to this one, I was changing the top row, so my instructions are lined up here. So I can multiply any row by a number. I can switch any 2 rows. I can take a row times a number and add the results to another row and come up with a brand new row. Okay. So let's do one. So here's a system of equations. This is easy. It's a 2 by 2. And I'm going to be honest with you. I probably wouldn't use Gaussian elimination on a 2 by 2. We have other methods. Linear combination, substitution, any of those would probably be preferable to this one. But I'm going to show you Gaussian in a 2 by 2 so you'll understand it. So the first thing you're going to do is you're going to take and simply put it into matrix form. Okay, and as we go along, there's going to be a method with what I'm doing and an order in which you do it. First thing I want to do is get a 1. I'm just going to write that over here. Get a 1. Remember when we were talking about our diagonals over here? I'm going to go back over this other page. So on a 2 by 2, there's my 1s. I'm going to get a 1 here first. How do you get a 1? Well, there's several ways of doing it, but for right now, to get a 1, multiply by the reciprocal. Okay. The reciprocal too. I'm working on this guy right here. I'm going to put dots around it. That means I'm working on that. To get a 1 there, I'm going to take 1/2, because that's reciprocal, and I got to multiply it times row 1. So 1/2 of 2, that becomes 1. 1/2 of -6 is -3, and 1/2 of -8 is -4. And right now we're doing one row at a time. The bottom row stays the same. So all I did is I multiplied some number times row 1, and that gave me these new numbers. Now I'm going to put a circle around here. And this is going to be called a pivot. We're going to talk more about that more here in a little bit. But we're going to use that pivot because now we want to get a 0 down here. So I'm going to put out here side, get a 0. Top row is going to stay the same. Now, to get a 0 here, we're going to multiply and add. When you go back to our rules right here, I'm talking about this one. You're going to multiply any row by a non-zero number and add to a second row. To get a 0 here, the magic number is going to be 5. I call it the magic number because I'm going to take 5 times row 1 and add it to row 2. The number that you multiply is really the opposite of whatever that is. So you could say multiply by the opposite and add. So 5 times 1 is 5. 5 plus -5 is 0. 5 times -3 is -15. -15 plus the 13 below it is -2. 5 times -4 is -20. -20 plus 1 is -19. So I got a 1 first, then I got a 0. Now I want to get a 1 again. So going back to this picture here, I got a 1, I got a 0, now I want to get a 1. And you'll always do it in this order. You'll get a 1 in this place before you do anything else, then you get a 0, and then you get a 1. And eventually we'll get a 0. When you get that point, then you're going to know what your answer is. So we already know we're going to work on the bottom row, so the top row is going to stay the same. To get a 1 here, you multiply by its reciprocal. So the reciprocal of -2 is -1/2. So -1/2 times 0 is 0. -1/2 times -2 is +1. And -1/2 times -19, the negatives drop out, and that becomes 19/2. I guess Up here I dotted that one. We were working on this guy. So I put dots around it. And then once you get that, that becomes our new pivot. We had a pivot up here. That's the pivot for column 1. This becomes the pivot for column 2. Now we got one more step. We got the 1, we got a 0, we got a 1, we got to get a 0 again. To get a 0, we multiply and add. What are we going to multiply by? We're going to multiply by the opposite of that number there, which is 3. Bottom row is going to stay the same. I'm just going to go ahead and put those in here. So we're going to take 3 times row 2, and we're going to add it to row 1, and we're going to put our answers in right there. So 3 times 0 is 0, plus 1, that's still 1. 3 times 1 is 3, plus negative 3 is 0. And then 3 times, this gets a little bit ugly, just go with me on this one. I got to take 3 times, sometimes you do this, I'm going to take 3 times that 19 over 2, and I'm going to add it to the number above, which was negative 4. That's going to be 3 times 19 is 57 over 2. Plus, think of that as negative 8 over 2. So when you put those together, that's 49 over 2. over 2. Okay, now take a look. See the ones on the diagonal? And you got zeros. This is in row reduced form or diagonal form. Got to catch myself there. Once you get into this form, then you know the answer. The answer is going to be, remember, it's an ordered pair, it's a point. And the x value is going to be 49 over 2, and the y value is 19 over 2. Ugly numbers, I'm sorry. 19 over 2. When you go back to this matrix here, what does that first row really mean? You know, at the very beginning, we went from algebraic equations to matrix form. Well, now we're in matrix form. If we went back to algebraic form, that means 1x plus 0y. So it's like x equals 49 over 2. This is 0x plus 1y, or just y equals 19 over 2. And that's how you do it. So that whole thing is how you solve using the Gauss-Jordan system. And I said there's rules that you got to follow. You always get a 1 in this position, a 0, a 1, and a 0. And it kind of changed pins here. We got this one first, this one second, that one third, and that one fourth. And you always follow the same rule, or the same order when finding this. We'll do enough of these, it'll make sense after a while. Okay, let's do one more. This will be a 3x3, and you're going to have trouble following all of this, but we'll just do the best we can. Okay, so you can see my equations there. So first thing I'm going to do, I'm going to write it in matrix form. So I'm going to have 3, negative 6, 9, 0, 4, negative 6, 8, negative 4, negative 2, negative 1, 1, and 7. What do we do first? We got to get a 1 right here. How do you get a 1? Usually you multiply by the reciprocal. The reciprocal of 3 is 1/3, so I'm going to take 1/3, row 1. 1/3 times 3 is 1. That's going to end up in my pivot, so I'm going to put a circle around it. 1/3 times negative 6 is negative 2. 1/3 times 9 is 3, and 1/3 times 0 is 0. And the other two rows stay the same. And I'm probably going to go a little faster than you can follow along, but I'm going to try to get through it. I'm always worried about my minutes up here on my phone as I record this. Okay, so the top row is going to stay the same. Now I want to get a 0 here. To get a 0, you multiply by the opposite. The opposite of 4 is -4. So I'm going to take -4 times row 1 plus row 2. Put my answers in row 2. So -4 times 1 is -4, plus +4 is 0. We knew that. -4 times -2 is 8. 8 plus -6 is 2. -4 times 3 is -12. Plus the 8 below it is -4. -4 times 0 is 0, plus -4 is still -4. Now we go to the next row. Now we want to get a 0 here. We multiply by the opposite, that's +2, so it's 2 times row 1 plus row 3. You may be asking, why are we multiplying by row 1? Because that's where the pivot was. That's why we have it. So 2 times 1 is 2, plus -2 is 0. 2 times -2 is -4. -4 plus -1 is -5. I'm sorry, did I do it right? Yes, I did. 2 times 3 is 6. 6 plus 1 is 7. And 2 times 0 is 0, plus 7 is 7. So notice what's happened here. Remember, we wanted to get 1s on the diagonal and 0s everywhere else? I've just finished the first column. I got a 1 here and I got my 2 zeros. Now we're going to work on the second column. Where do we want the 1 at? We want the 1 where the 2 is. To get a 1 there, you multiply by the reciprocal. So 1/2 row 2. Top row is going to stay the same. I'm working on this guy right here. So 1/2 of 0 is 0. 1/2 of 2 is 1, and that's going to be my new pivot. That's the pivot for row or for column 2. 1/2 of -4 is -2. 1/2 of -4 is -2. And the bottom row stays the same. Okay, now you want to get 2 zeros. So from here to here, we got a 1. From there to there, we got zeros. From here to here, we got a 1, and it rotates. Now we want to get zeros. I got the 1 in this column, so I want to get a 0 above it. To get a 0 where the -2 is, the opposite of -2 is +2. So I'm going to take 2 times row what? Where's the pivot at? It's in row 2. I'm going to add it to row 1. That gives me a 0 up here. So top row stay, I say 2 times 0 is 0, plus 1, that's going to be 1. 2 times 1 is 2, plus -2 is 0. 2 times -2 is -4, plus 3 is -1. And 2 times -2 is -4, plus 0 is -4. Middle row stays the same. By the way, you cannot change all 3 rows at the same time. There's times you can change 2 of them. We're going to change 2 of them now. When you get zeros, you can do more than 1 row. When you're getting a 1, you only change 1 row. Okay, bottom row. I want to get a 0 where the -5 is. The opposite of -5 is 5. So I'm going to take 5 times row 2. I'm going to add it to row 3. Put the answers in row 3. 5 times 0 is 0, plus 0 is 0. 5 times 1 is 5, plus -5 is 0. 5 times negative 2 is negative 10. Negative 10 plus 7 is negative 3. 5 times negative 2 is negative 10 plus 7 is negative 3 again. So at this point, notice, first two columns are done. I'm getting that diagonal thing where all the ones are zeros, or ones, and everything else is going to be zeros. Okay, should have two more steps. Also, you'll notice when I do this, I know this doesn't look very, very neat, but I try to go on an angle, and I did. That way, these don't get blurred into there. When you get done, sometimes it's hard to follow. Okay, I'm running out of room. So, what's next? I want to get a 1. I want to get a 1 right here in the third column. The 1's always at the bottom. So I'm going to take negative 1/3 times row 3. Row 1 stays the same. Row 2 stays the same. And row 3 becomes negative 1/3 times 0 is 0. Negative 1/3 times 0 is 0. Negative 1/3 times negative 3 is 1. That becomes my new pivot. And negative 1/3 times negative 1/3 is 1. Going back up here, we got a 1, we got 2 zeros. We got a 1, we got 2 zeros. We got a 1. The last step is we want to get 2 zeros. And you'll notice it alternates like that. Okay, let's get the last step done, and that'll be the end of this lesson. Okay, now the bottom row's done. We're not going to do anything else to that. I got to get a 0 here using that pivot. All I have to do is take 1 plus negative 1 to get a 0. So that's row 3 plus row 1. And we'll put the answers there. 0 plus 1 is 1. 0 plus 0 is 0. 1 plus negative 1 is 0. 1 plus negative 4 is negative 3. To get a 0 here, I have to multiply by 2 and add. So 2 times row 3 plus row 2. 2 times 0 is 0 plus 0 is 0. 2 times 0 is 0 plus 1 is still 1. 2 times 1 is 2. 2 plus negative 2 is 0. And 2 times 1 is 2 plus negative 2 is 0. Now, we're done. See how I got the 1s on the diagonal and zeros everywhere else? And what I say these were? Those are the answers. Now, the answer on this one, the other problem, it was an ordered pair. On this one, it's an ordered triple. Here's X, Y, and Z. My ordered triple is -3, 0, and 1. Or you could write out and say X equals -3, Y equals 0, and Z equals 1. Okay, I've probably taken you a little bit more than what was in section 2.1, but it'll make section 2.2 easier for you. And I'm going to stop there because I'm probably out of time.